Okay, in 12.2 we're going to cover multiplying and dividing these rational expressions. How to multiply and divide these rational expressions. All right, let's look first and remember just our elementary and middle school skills. How do you multiply fractions in general? If you have two fractions, let's say 2 over 5 times 3 over 7, it's very simple. You simply multiply straight across. The 2 multiplies with the 3 and gets 6. The 5 multiplies with the 7 to get 35. And you end up with simply 6 over 35. All right, so it's a very simple thing to multiply fractions. We're going to take a similar approach to what we're doing in these algebraic expressions with variables in them. All right, 4x over 5 times 7 over 6x to the fourth. Okay, I would recommend before you multiply across to see if anything can reduce. And listen to this, anything on top can reduce with anything on bottom. It does not have to be directly over it. It can be diagonally over it. So like the 4x could reduce with the 5 or the 6x to the fourth. The 7 could reduce with the 5 or the 6x to the fourth. But let me say this, you cannot reduce two things that are both on top or two things that are both on bottom. To reduce things, one of the things has to be on the top and one of the things has to be on the bottom. So what I would say that you should do is the 4 and the 6 can reduce each other. The 4 and the 6 can both divide by 2, right? The 4 and the 6 can both divide by 2. And what do those two things become? Those two things become, let me get me a different color here. That 4 divided by 2 becomes a 2. That 6 divided by 2 becomes a 3. All right. What else can reduce? The x and the x to the fourth. Subtract their exponents. What's the exponent of that x? It's an understood 1, right? So the 1 and the 4 need to subtract, and it reduces to what? X to the third. Where does it go? It goes on the bottom. So that x to the first cancels out completely. That x to the fourth reduces to x to the third. So now, what am I left with? I am left with 2 over 5 times 7 over 3x cubed. Now, nothing else can reduce, and I should go ahead and multiply straight across. It leaves me with now 14 on top and 15x cubed on bottom, and that's my answer. And that's the completely reduced answer. Okay, let's get us another example. Let's do us another one of those before we go to a different kind of example. Let me make one up. How about 8x to the third over 10y squared times 15 x squared y over 12. How about x to the seventh, and leave it at that. All right. Remember, anything on top can reduce with anything on bottom. You have actually a lot of choices here. You could reduce the 8 and the 10, or you could reduce the 8 and the 12, or you could reduce the 15 and the 10. So just start somewhere. I think I'll go ahead and reduce the 8 and the 10. The 8 and the 10. So I can divide both of these by 2 so that the 8 becomes a 4 and the 10 becomes a 5. Okay, I can keep going. The 5 will also reduce with the 15. So the 5 will reduce with the 15 by dividing. Let me get a different color. Let me do this. By dividing by what? By dividing by 5. So now the 5 becomes a 1, and the 15 becomes a 3. What else could reduce? The 4 and the 12 could reduce, or the 3 and the 12 could reduce. And it doesn't matter which one you pick. You're going to end up with the same answer at the end anyway. So whichever way you want to go here. I think I'll go with the 3 and the 12. All right. I'll divide those both by 3. And that becomes a 1, and that becomes a 4. Okay, now look at your variables. Look at your x's. I'm going to go ahead and reduce the x to the 3rd and the x to the 7th. They will subtract and beget x to the 4th, and it will go on the bottom where the x to the 7th was. So that x to the 3rd is going to cancel completely, and the x to the 7th is going to reduce to an x to the 4th. Okay. Also, the x squared can also reduce now with that x to the 4th. So the x squared and the x to the 4th, subtract the exponents. The x squared cancels completely. The x to the 4th is going to become an x to the 2nd. All right. That's all the reducing I can do with the x's. Look at the y's. All right, the y squared on the bottom here can reduce with the y on top here. So y understood to be a y to the 1st, right? So they subtract the exponents and you get y to the 1st, because 2 minus 1 is 1. So you just get y to the 1st power. So this cancels out completely, and the y squared becomes a y to the 1st. So now what do I have? I have 4 over y, or 1y. If you want to leave it as a 1y, that's fine. You can leave the 1 off if you want. Times what's left here. The only thing left on top here is just 1. What's left on bottom here is a 4x squared. And there's actually one more reduction I can make in there. And I didn't see it before, but I see it now. That 4 can reduce with that 4. Divide them both by 4. And that becomes a 1, and that becomes a 1. So I'm now left with 1 over y times 1 over x squared. There's no more reducing I can do, so now you just multiply straight across. On top, 1 times 1 is 1, so you get 1 on top. On bottom, y times x squared is just x squared y. You could put yx squared, but it's normally you put the variables in alphabetical order, so the x comes before the y. So 1 over x squared y is my final answer there. I know I made up a fairly complicated example there, but hopefully seeing all that can make the other examples not seem, it took you through a lot of things to help you see everything that's going on, and the other examples will not be so bad. All right, let's do example 2 here. All right, I've got 2x plus 6 over 3 times 6x over 5x plus 15. Remember what I said. If there are pluses and minuses involved here, what should you do first? If there are pluses or minuses involved, you should factor first. Factor everything on top that you can factor. Factor everything on bottom that you can factor. Okay, so I'm going to do that. In fact, let me get more room. Okay, I'm going to factor the 2x plus 6 by factoring out the GCF, which is a 2. So this is no longer going to be that. It's going to be a 2 on the outside and an x plus 3 on the inside. I can also factor the 5x plus 15 in a similar fashion. The GCF of 5x plus 15 is 5, so I bring a 5 out and I'm left with x plus 3. Okay, I'm scribbling that out so that I'm not looking at that anymore. I'm now just looking at the other thing I've written in its place. Now what things can reduce each other or cancel each other? All right. The 3 and the 6, that 3 and that 6 can reduce each other by dividing both by 3. So that 3 now becomes a 1. That 6 now becomes a 2. What else can reduce each other? The x plus 3 on top here and the x plus 3 on bottom here. Okay? Can cancel each other. So the x plus 3s are gone. They're canceled. I think that's all the reducing I can do. Let me rewrite my equation. I got 2 over 1 times 2x over 5. And I believe that's all I can do, so that I get 4x over 5 as my final answer there. All right, let's do this example 3 here. All right, I copied and pasted that problem. Don't worry about that right there. That's just something that was left over from where I copied it and pasted it. Don't worry about that right there either. Okay, so I want to factor. Why don't you go ahead and try? Why do I want to factor first? Because there are pluses or minuses involved in these expressions, so I must factor them first. Why don't you go ahead and try to factor the top left and the bottom left and the top right and the bottom right. I'm going to rewrite these. The x squared minus 49 factors as x plus 7, x minus 7. The 5x minus 10 factors as the 5 on the outside and the x minus 2 on the inside. The top right, the x squared minus 2x, I factor out an x as the GCF, and it leaves me with x minus 2 on the inside. And the bottom right, the x squared minus 9x plus 14 factors as x minus 7 and x minus 2. So now just start crossing things out, reduce things. Anything on top that's the same as anything on bottom. So that x minus 7 can cross out that x minus 7. That x minus 2 can either cross out the one directly under it or the one diagonal from it, but not both. I'm just going to cancel out that one. I could have easily just canceled out the one over on the left side too, but you just can't do both, just do one or the other. What else? Is there anything else that can cancel? I don't see anything else that can cancel. So the answer I'm going to write is multiply straight across. I'm just left with x times x plus 7 on the top there, and I'm left with 5 times x minus 2 on the bottom there. I can leave that as the answer. This is a good answer. Or if you want to go ahead and distribute, I can go ahead and distribute that, and it could be x squared plus 7x on top over 5x minus 10 on the bottom, and that's another good answer. So either way, both of these are good answers. Okay, let's see if there are any other more good examples in this unit. Yep, go ahead and try example 4 there. Okay, factor the top left and bottom left and top right and bottom right. How does it factor? The top left factors as a difference of squares, 2x plus 3 and 2x minus 3. The bottom left, I factor out a GCF, which is 2, and it leaves me with x minus 5. The top right factors as x minus 5 and x minus 5. And the bottom right factors as, that's going to be, I'm going to have to do the AC method there. Take the 2 and multiply it down there. That's going to be x squared minus 7x plus 12. That's going to be x minus 3, x minus 4. Then don't forget to divide the 2 back out of there. So this is going to become 2x minus 3 and x minus 2. This one reduced, and that one I had to move the 2 in front of that x. Okay, now see if there's anything that can reduce each other. Can anything cancel out? Yes, the 2x minus 3 and the 2x minus 3, the x minus 5 and the x minus 5. I don't see anything else that can reduce. So my final answer here is 2x plus 3 times x minus 5 on the top and 2 times x minus 2 on the bottom. That's going straight across. Top times top, bottom times bottom. If I want to go ahead and FOIL this out or distribute this, I can. This is a good answer. but I could also distribute and get 2x squared. So that's minus 10x plus 3x minus 7x minus 15 over 2x minus 4. And this is also a good answer. Both of those are fine for your answer. Okay, let's see. Now we're going to talk about dividing. If you can multiply, you can divide. Dividing fractions is going to be the same kind of process as multiplying fractions. Why? Let's remember, how do we divide fractions? How do we divide fractions? Some of you call it keep, change, flip. Others of you call it multiply by the reciprocal. Okay, so let me show you what I mean by that. All right. Again, some of you call it KCF, keep, change, flip. That means you keep the first fraction. Then you change the multiplication to division. Change the division to multiplication. And then you flip the second fraction. Keep, change, flip. So 15x cubed over 2 times 4 over 35x to the 7th. Keep, change, flip. Others of you might call it multiply by the reciprocal, which is the same thing. It means instead of dividing, you multiply by the reciprocal of the second fraction. That's the same thing as keep, change, flip. In any case, what you do before you start anything else is you change it to multiplication and flip the second fraction. Then it's the exact same thing we did earlier. You're just multiplying the same way. So I would say the 15 and the 35 can reduce each other by dividing both of them by 5. So that the 15 becomes a 3, the 35 becomes a 7. The 2 and the 4 can reduce each other by dividing both of them by 2. So the 2 becomes a 1, the 4 becomes a 2. And the x cubed and the x to the 7th can reduce each other by subtracting their exponents, so that the x cubed cancels out completely and the x to the 7th becomes an x to the 4th. Now it's going to be 3 over 1 times 2 over 7x to the 4th, and that's going to equal 6 over 7x to the 4th, and that is the answer. All right, what's the first step? Change it to multiplication and flip that second fraction. So let me do that first before I do anything else. Otherwise, I will be wasting my time. X plus 1 over x squared minus x minus 6. I will be wasting my time trying to do any other work on this problem unless I do this first. Now, what should you do next? You should, because there are pluses and minuses involved, you should factor. Factor everything you can factor. Okay, so that x squared minus 9 will factor as x plus 3 and x minus 3. So I'm not going to look at that anymore. The x squared minus x minus 6 can factor as x minus 3, x plus 2. So I'm not going to look at that anymore. And the 3x plus 3 can factor as I factor a 3 out, and I'm left with x plus 1 in the inside. So I'm not going to look at that anymore. Now, what can maybe cross out? The x plus 1 can cross out with x plus 1. The x minus 3 can cross out with x minus 3. That's the only crossing out I see. So I'm left with what? I'm left with x plus 3 on top. And on the bottom, I'm left with a 3, and I'm left with an x plus 2. So that's my answer. Or if you want to distribute the bottom, you can do that. 3x plus 6, and this is an equivalent and an equally good answer. Both of those are good. All right, are there any more examples we can do? Let's look. I think there might be. Yeah, a few more actually. Remember the first thing I do here? I change it to multiplication and flip the second fraction. How do I flip this second fraction? There's nothing on the bottom. Well, yeah, there is. You can always put it as being over 1. Okay, so now we can flip that second fraction. So now I can write it as x squared plus 6x plus 9 over x minus 4 times 1 over x squared plus x minus 6. So if the second fraction is not a fraction, you can always put whatever that thing is, you can always put it over 1. Because anything over 1 is the same thing, it's itself. So put it over 1 and then you can flip it and make it be 1 over that thing. Now factor the heck out of this thing. Okay, so how does this factor? It factors as x plus 3. Let's see, I can get a better pen here. Factors as x plus 3 and x plus 3. So I'm not going to look at that anymore. And the bottom right factors as x plus 3, x minus 2. I'm not looking at that anymore. So what can now cross out? I can cross out the x plus 3's, that x plus 3 with that x plus 3, and that's all. That's the only thing I can cross out. So my final answer here is going to be x plus 3 on top, because x plus 3 times 1 is still just x plus 3, and on the bottom it's x minus 4, x minus 2. Alright, so if this is a good answer, if I want to distribute the bottom, it could be distributed, and I could get x squared minus 6x plus 8 on the bottom, and that's a good answer as well. All right, here's another example. All right, let f of x equal this expression, and let g of x equal this expression. I'm gonna make one change here to make this a little easier problem for us. Let me make that be 9x minus 7 instead of 7 minus 9x. All right, let me do it up here. So g of x equals 9x minus 7 over 18x plus 6. That's going to make this, otherwise we'd have to get into a different concept that I don't need to teach you right now, and it's just going to confuse you more. So that'll take care of it. So it says find an equation of the quotient function f over g. Find an equation of the quotient function f over g. So f over g is the same thing as f divided by g. So that would be 81x squared minus 49 over 3x squared plus 16x plus 5 over 9x minus 7 over 18x minus or plus 6. This is the same thing as divide. It's division. So I'm going to do the same way as if it was this divided by this, which is again, change it to multiplication and flip the second fraction. I'm going to keep the top fraction. I'm going to change this division thing to multiplication, and I'm going to flip the bottom fraction. So I've got 81x squared minus 49 over 3x squared plus 16x plus 5 times, I'm flipping this, so I've got 18x plus 6 on the top over 9x minus 7. Now I got to factor like crazy. The top left will factor as 9x plus 7 and 9x minus 7. Okay, difference of squares. The bottom, I'm going to have to do the AC method. So the 3 is going to multiply down there with the 5. I'm going to get x squared plus 16x plus 15. So it's going to be x plus 15, x plus 1. Don't forget to put the 3 back under there and reduce or move the bottom in front of the x. So it's going to be x plus 5 and 3x plus 1. So I'm going to scribble that out because I'm not looking at that anymore. The top right, I'm going to factor out a 6, and it's going to leave me with 3x plus 1. So I'm not looking at that anymore. And the 9x minus 7 on the bottom there will not factor. So now what can cross out? The 9x minus 7 on the bottom here can factor out with that, can cancel out with the 9x minus 7 on top there. The 3x plus 1 there can cancel out with the 3x plus 1 there. So I think, wow, what happened to my screen? So I think I'm ready to write the answer. On top, I've got 6 times 9x plus 7. On the bottom, I've got x plus 5. If I wanted to distribute, I could rewrite the answer as 54x plus 42 over x plus 5. And either one of these is a good answer. So that does part 1 for me of that example, but there's also a part 2. All right, part 2 says this. It says find f over g of 3. So if I find f over g of 3, I've already found f over g. I found f over g in the previous step. Now all I have to do is plug 3 into what I've already found in the previous step. Just plug 3 into this right here is f over g. I think I'm going to use this one because I think it'll be a little easier than using the top one. So just plug 3 into x in this expression that I already found in part 1. So it's f over g of 3 is going to equal 54 times 3 plus 42 over 3 plus 5. So that's going to be 3 times 54 is 12. Okay, 162 plus 42 over 8. And that's going to be 204 over 8, and that will reduce if I divide both of them by 4. 4 goes into 250 times, so it goes into 2 over 4. 2 over 4, 51 times, so 51 over 2. And that is my final reduced answer for that part. And that's my last example for section 12.2. Good luck on that assignment. I'll see you again in 12.3.